Assalamu alaikum, boys and girls. We are still talking about electrostatic tool, and today we're talking about capacitors. I remember the other day in the previous lesson we were talking about how the storage of energy can be done by some of the electrical components. And the capacitors is one of the examples of electrical components that usually store energy that of course when we require it, of course we can now use it. But before that, I want us to look at what you call the lighting arrestors. You are actually seeing what we call the arrestors in tall buildings, something like this, tall buildings that of course will have to assist when it comes to lightening. Of course we have the copper metal that has to be buried into the underground, but of course we have these sharp points that of course we like them to actually attract all the electrons, what you call the discharge. So the electrons will actually, those charges will actually go through the spikes at this point, and of course will be discharged or neutralized at the underground where we have the copper plate. But of course we are saying that lightnings are used a very discharge where a large amount of charge rushes to make the opposite charge. That actually happens, and actually use the lightning arrestors to neutralize the cell. It can occur between the clouds or even the cloud and the earth, and sometimes lightning may not be prevented, but protection from infiltration may be done through the arrestor. We are saying that when you go to some places where we have a lot of rain, we have a lot of lightning, like Rift Valley in this country, you realize that there's a lot of lightning. So for the houses to be prevented from the lightning effect, what we do is we have what you call the lightning arrestors. In case we have those charges coming from the maybe a lot of clouds coming from the other side, if attraction or even repulsion takes place, it will be just, the charges just go through the arrestors and of course will be neutralized by the copper plate under the ground. Remember, inside the ground we have a lot of electrons which you call the negative charges. So either the electrons can be moved upwards or can move downwards depending on the nature of effect that is happening up here. So that if there is any attraction, these are positive charges, of course what will happen is the negative charges will have to move up and of course will neutralize the effect, and of course there will be no effect on the buildings and so forth. An arrestor consists of the thick copper strip, which is here, I just explained, that actually are buried under the ground, so that now you see this is copper, and we know that copper is very good conductor. It has a lot of free electrons. That's why now that under the ground there's a lot of negative charges. So that now this being a very good conductor, what will happen is likely either to transmit under the ground or transmit up to the spikes in case we have lightning happening just near or close to the arrestor. Now you can see from here. This is just what I was explaining. You can see that these are building, these are copper plate underground. Then of course you have the copper chip. This is where we have the sharp points. And remember when you're discussing about the distribution of the charges, we realize that if you have a sphere which is regular, of course we are having that the charges will be distributed evenly along the surface, of course inside. But of course when you have a pear shape, what will happen is this is pointed, so this sharp, so the charges will be very close, will be actually heavily distributed at the sharp point. So we are saying that when you look at the arrestor, this part here is where you expect that we have a lot of charges, especially negative charges that will be there, so that if in any case, of course, it will be either go to the underground or of course will happen the neutralization will take inside the air, whereby we have the cloud, maybe there are positive charges, positively charged, then when they are coming close to each other, there is punction. Then you have that a form of a lot of the charges just coming off of the cloud. So we are saying that one can only happen then we have what you call the copper plate that is open. It's likely to distribute, likely to neutralize the lightning. Now we say, back to my point, what is a capacitor and what is a capacitance? We are discussing that. A capacitor is a device for storing charge. I have two capacitors here. Two capacitors. This is an example of a capacitor. If you look at it very clearly, you are likely to see that it has a value. The value is 2200 2200 microfarad. Of course, we'll be discussing about the units for capacitors. Of course, this one is a 2200 microfarad. Even this one here is the same. Of course, they have indicated that 2200 microfarad. They have indicated that this is 25 volts. And of course, this is an example. I know if you open any electrical component, you might have seen such cylindrical objects. Maybe you're wondering what is this? This one is a capacitor. This one is a capacitor whereby we require, it stores energy. We are saying that this one is storing the charge, of course. So that now when we require the charge in form of energy, what will happen is we can now take it from where? From this particular capacitor. Sometimes, maybe. A very good example is a power bank. Power bank, we say we are going to charge the power bank. This one is just an example of the capacitor that actually installed inside here. So that now when the power bank doesn't have the charge, what happens? It cannot charge the phone, mobile phone. So, but if this power bank has a lot of charge, it can be used to charge a mobile phone. So we are saying that this is just an equipment or electrical gadget that it uses what you call, it has several capacitors inside here. So that now we can charge it for some time, then it will store some charge. But when we require that charge, what we need to do, we simply have the connecting wire, we place it in the mobile phone, then from there we are going to discharge it. But of course, as we are discharging this, we are actually charging the mobile phone. So this one is actually a very good example of a capacitor equipment, that the capacitors have been installed here, so that now when we require the charge, we can now derive it, we can actually drain it from where? From this particular equipment. We see that it consists of 2 or more plates separated by what we call either vacuum or air. And the symbol for a capacitor is very simple. This is a symbol for capacitor. Please don't confuse. This is a capacitor. Don't confuse with this. This one is what? This one is a cell. This one is a cell. This one is a capacitor symbol. And of course, we know that a cell and a battery are totally different things. A battery, at least one dry cell. This one is a cell. One dry cell, that is a cell. But if you make it 2 or 3, this one will not be a cell, but we call it what? We call it battery. So yeah, those are different. Now we need to see that these plates, these parts here, they are equal, no, unlike for cell and for battery. Now you're saying that these are just 2 plates. You can actually see from the diagram 2 plates, but of course they are separated by either vacuum or air. The insulating material is called dielectric material. They are symbolized as shown below. So these are the capacitor symbol. We have the plates, which are equivalent in terms of the length. So this is the equivalent. Then from there we have the connecting. Terminals, positive, negative. Then from you connect to the other part. Don't confuse, please, with the cell or the battery in that case. Now we are saying that it's important for you to notice that there is a separation between the plates. It could be either air, it could be either vacuum, it could be either material. We'll be discussing about the types of capacitors shortly. Now, as we move on, we are saying that how do we determine capacitance? We know capacitor, and we'll go back to electricity, current. There is somewhere we were saying that how do we determine the resistance, for example, V divided by I. Of course, we say that V is equals to IR. I remember this, we say that will be the Ohm's law. At the same time, we know that in quantity, in electrostatic 1, there's somewhere we say that the quantity of charge is what? Is IT, whereby this is current and this is time. Now we come to what we call the capacitance, C. We say that capacitance C is actually Q divided by V. From the screen here, you can see that capacitance is equals to Q divided by V, where Q is the charge and V is the voltage. Right? So, but of course, as we are going to move on, we are going to determine that what is this Q? Q, of course, we know it is what? Is IT. We are going to determine that. And of course, V is actually the what? Is actually the voltage. We are saying that this is the formula for getting capacitance. Please, we are saying that there is a capacitor is this apparatus. Right? It's, for example, an ammeter. An ammeter is an equipment that measures current, the flow of the current, the amount of current. But of course, an ammeter measures current. We are saying that capacitance is actually the quantity of charge stored by a capacitor. We are saying that is here. The C is equal to quantity of charge per volt. So that now we are saying the unit for capacitor are actually coulombs per volt, which we call the farads. The unit for capacitor, this one we call it a farad. F-A-R-A-D, farad. And you see, as we are calculating, we do calculation, we narrow down that of course we don't need the farad, we need what we call the microfarad. These are 10 times -6. We'll be discussing about that when we discuss about calculation. We are saying that quantity of, the capacitance is 1 coulomb divided by 1V, which we call 1 farad, but of course we are saying that 1 farad is actually 1 coulomb, we divide by 1 mole. And of course we are saying that we don't need, farad is a very good value, so that we simply use 1 microfarad. So 1 microfarad is what we usually use. We are saying that 1 microfarad is actually 10 times 6 farad. In most cases, we actually use microfarad during our calculation. I remember stating that this particular capacitor is a written 2200 microfarad. So those are the units that we are likely to use. Okay, we have what we call 1 picofarad. Picofarad, those are very small values. Pico is a micro of a micro. So we are saying that this one is a 10 power negative 12 farad. So that is very small unit that of course we'll be discussing in shortly. Now we are moving forward briefly, then we'll be discussing about the types, then we move on charging and discharging. Thank you.